tempered, restricted, and various other versions of this. Thank you so much. That's one. Well done. So this is the bonus talk, which means what Benny said. At this point, everything is fair game, but and we'll see what happens. So the plan is to introduce some other versions of the geometric Langlands conjecture. We'll see that the proof of the Durand geometric Langlands conjecture kind of goes between. Oh yeah, these are the other ones. There's Durand, there's Betti, restricted, and centered. The goal is to introduce the other three. Betti, restricted, and centered. So they all kind of fit together a little bit. And yes, that's right. So start with the Betti version. So the Betti geometric Langlands conjecture was introduced by Benzi and David Adler in 2016. The setup is as follows. So X is a smooth projective curve as usual. The sign will be complex units. And we fix E an algebraically closed field of characteristic 0 to be thought of as the coefficient. So the goal is to define a version of geometric Langlands replacing log says G check, as we've seen before, to run local systems on the curve with Betti local systems. So we'll define that in a second. We know that log system check Betti to be thought of as a space of maps from pi1 of x to G check. So let's define the spectral and the automorphic side of the Betti geometric Langlands conjecture respectively. So the stack, let's just check Betti. All right, it's a space of maps of spaces, homotopy types, X to be check. Formally, I mean the following. So a map from S to this algebraic stack works as Betti. It's the same as a map of spaces from X to map of stacks from S to B to check. This is the groupoid of G check bundles on S. It's a little much. So the following alternative presentation might be a bit better. Alternatively, let's write G for the genus of X. Then fundamental group of X, which is generated by AI to BI by going from 1 to G, such that their commutator is 1. Okay. So if you think of what it takes to give a map from pi1 to a group, it will be the following. Namely, we have to specify two G elements of G check, one for each generator. And it should satisfy one relation. Namely, when you map this product to G check, so it's the obvious map given by the product of the commutators, you should get one. Okay. So from here, we also see the derived structure of fluxes, not a classical stack.
Hard to check.
Hard to check, thank you. Hard to check. You only want to consider it. You have it everywhere.
But it's basically just a probability that.
Yes.
What is this probability that potentially depends?
Yes. This is complex analytics. I look at it, it's topological space on the line.
Also, James should be
No. And this is a point I'm looking at. That'll come up now, actually, but then the point times point over the check. That's coming literally now.
Okay, sorry.
Yeah, so it works for energy. Yeah, so let's do that example actually. So if we take X to be P1, what we see is that log says G check Betti is just point over G check point modulo G check, perfectly fine. I'll write this as the loop space of the real algebra of the G check. I think we've seen this before in the round 7 as well. Another example is if G is a torus. Let's look at the presentation in this case. The log says G check Betti, T check. It's that fiber product up here. But this map is trivial because T check is a dealing. So we'll just get this copy here times the loop space of T check. And also the conjugation action is trivial, so we'll just get a factor of the classifying side. Okay. That's the spectral side. Go to the orthomorphic side. So the orthomorphic side of the Betti geometric Langlands conjecture will be some subcategory of sheaves by G. And so let's review by what we mean by sheaves in the setting. If you have Y over the complex numbers, let's say an algebraic stack, locally a finite type, say. I'll write sheaf all on Y to be this is the category of sheaves of E vector spaces. So E was this field there, fixed from the beginning, a coefficient field.
I think what's if I look at it as the complex points, it is nothing characterizing, and it looks the same. What's the
What logs is Betti and logs is wrong? Yeah, so that would be the Riemann-Hilbert.
yeah, to the
Yeah, so the Riemann-Hilbert corresponding gives an equivalence of categories, if you will, between representations of the fundamental group of X, projective, and vector bundles with a connection on X. That tells you that the complex form that looks as Betti and looks the wrong one side. A bit more on that later. So we'll utilize this to connect the Durham and Betti sides. We finish this sentence, so we'll achieve all Y with the category sheaves of E vector spaces on in some logical space underlying this topological space.
Right, you mean quadrangular stack.
Again,
You take the quadrangular stack.
I should take what?
Quadrangular stack.
Okay, so maybe I should say a bit more precisely what I mean. So, we can do i.e. really defining it as follows. The limit of all smooth schemes mapping to Y of sheaf all on S. So I just formally reduce the K to S as an affine scheme, for example, where you okay. And next we'll introduce some singular support condition. So if lambda is some closed canonical subset, then we consider the following subcategory. Namely, I'll write sheaf gamma all on Y. So this is the category of sheaves on Y such that the singular support of each homology is contained in gamma. So this is singular support in the sense of Cauchy-Shapiro. I'm gonna take the liberty of not defining that because it's a bonus time. So everything is fair game. It's a certain subcategory. And well, one thing to say about it, I suppose, is that if lambda is Lagrangian, then such sheaves are automatically constructible. Okay. Now let's specify to Y being 1G. So let's recall how the potential space looks 1G. Recall that the tangent space of 1G parameterizes points, a bundle, and a Higgs field. And this is a global section on an omega twisted one form on the adjoint bundle of G. And we take lambda to be nil. This is the closed canonical subset of, well, those pairs, which is phi is nilpotent. It's similar to how Dima defined the nilpotent cone in his talk from the coherent side. Okay. And with this, we can define the Betti geometric Langlands projective. So it says something similar to the Duran one, except the main key difference, in some sense, is that your closest nilpotent singular support condition on the automorphic side. Okay. Any questions about this conjecture?
maybe just one comment that people can do this stuff. So the formula for T star by G, I don't think I've heard before, but just to explain that the tangent space by G. And with exercise, use this formula quite just in the. We'll give you that.
Are you asking me to do that?
No, just make the comment.
Alright. Okay, let me get a bit of motivation for this nilpotent singular support condition. Seems a little bit random and is in fact a bit mysterious. Motivation. One is that Le Monde in 87 conjectured, and this was proved in this paper, HPRE from 2020, ranking against Dorica Stammlast and Josky, that headline issues have no problems in those support. And in fact, the converse holds true. The second motivation is the same one that appeared on the coherent side. And then we would have an Eisenstein series from going from sheaves and 1n to sheaf and 1g. Whenever you have a parabolic B. And this preserves the opposing. As you would want for this kind of statements, please. Okay. Any questions about this?
So I mean, is the conjecture proven or is it certain, like the Betti?
These are all proven at the end of the day.
Okay.
At this point. And yeah, one motivation for introducing them is that the logic of the proof kind of goes between them. And go back and forth. A little more about that later.
But they only proved as a consequence of the main theorem, right? Or
It's kind of, there'll come some restricted version a little bit, which in turns out to imply both, and they're kind of all proven at the same time. So, yeah, but you showed that the restricted one implies both. And
why the new thing? What's the difference with previous version of GLC? Why does the new thing doesn't appear there?
in that round.
Yeah.
One way to say that,
It seems like your motivation also applies there, right? Or
yes. I mean, one way to say that is this theorem, and I would state half of, which says that having nilpotent with support implies that the head action on the sheet is locally constant. And this is just something that's not true in the drum setting. And yeah, there are other kind of technical things to say. I won't try to come up with.
You can say for the torus, right? For the torus, we see what's going
Yeah.
on.
Okay. Yes, the torus, the Joakim dimensional Langlands just boils down to the Freudian power equivalence. And in fact, we'll do the torus case now for the Betti. This is the first technique he do, check it when he do his healing, and we'll see it holds true there. So in this case, he's going to call it bones by zero. So let's compute both sides of the Betti geometric Langlands conjecture and just check that they comes out. So we saw that the Betti moduli stack was this triple product.
Maybe it's a different way. If people haven't seen this before, it might be helpful to just, when you say, like. For just, like, instead of one G, just for just the root G itself, like, it was already well known in the 70s and 80s, but like special sheets in G, for which you care about, character sheet or whatever, they all have this kind of no single support. Like, the analytical local system of the torus is having no focus in the support, looking at these are all sort of local analogs and pictures that people already knew for about special functions in the sheet.
Yeah, so, okay, so there are these. Yeah, I mean. So there are these character sheets on the group, and they're characterized by having nil potency support. This nil potency support condition appears in geometrical representation period 4. And in fact, if you specify X, to curve, you kind of cover the story a little bit. But even then, it's not entirely, still bit of a bold guess. So. Yeah. Okay, let's continue with this. If you take quasi-domain sheaves on Rose's Betti, well, what do we get? We get a trivial product of these things. Let's just compute each one. So this one here, it's not so easy to see, is modules for the group algebra. The first homology tends to the co-weight lattice. Now, this one here, well, by definition, is the same shifted by one mod. What's the first the third factor? Well, that's representations of T checks, so these are just co-weight lattice derivation process. Okay. Any questions about that decomposition so far? Let's continue to over time. So one T in this case also has a decomposition. So it's degree 0 T bonds on X times the classifying stack for T, and then the co-weight lattice, using the quantity. So let's consider sheaves on T to all whose singular support is contained in the zeros. I should say that one characterization of a sheaves of E vector spaces to be a local system is that its singular support is contained in the zeros. So we'll get sheaf 0 on each of these factors. Sheaf 0 on this one will be modules for the group algebra of pi 1 this sheaves on ET with a module for homology of T, and then at last we'll get vector spaces created by the co-weight lattice. And now it just remains to see that see pi 1 of T is homology of X tensor co-weight lattice, and that the homology of T is say of T shifted. These method. Okay, so this is just the same, except that the conjecture is true in this first stage.
How would this change? We looked at not the Betti version, but the ground version.
Well, it wouldn't change that much, except these factors are a little bit uninteresting. In that case, we reduce the usual Fourier transformation, Riemann transformation. It gives an equivalence between D modules of the Jacobian and quasi-covariant regimes when one connections. In some sense, that's more difficult because you use the Fourier transformation, and this was kind of stupid. Okay. Any other questions?
So in this torus case, is then Riemann-Hilbert just equivalence that identifies the two sides?
So in the torus case, we gave an equivalence, yes?
Like does Riemann-Hilbert define morphism of
Not,
X?
not quite yet, and the reason is that we're considering not just local systems, but these are arbitrarily bad local systems, not finite random. Riemann-Hilbert correspondence gives a equivalence between random representations of the fundamental group, algebraic vector bounds for connections. So we can't apply Riemann-Hilbert yet, but we'll do that in a second. We have to. Yeah, so the next thing will be to introduce this restricted geometric Langlands conjecture, which talks both to the Duran one and the Betti one. You can't yet apply Riemann-Hilbert, so we need some intermediate category, which turns out that the conjecture for that is equivalent to the Duran one and the Betti one. That's the connection.
And this also touched on Berger's question before, there's folks that study that you find it.
Yeah.
And there's folks that surround that didn't find it. The two are complex analytically isomorphic, but they are not algebraically isomorphic. When we talk about quasi-covariant sheaves, it really uses the algebraic structure. We have different categories. Spectral side, even though if you think a little too naively, they look really good.
Right. Yes. Yeah. So we need some intermediate setting, and you might be a little bit worried that because of this remark of Sam, the Weber version, the spectral side would have to be a little bit stupid. I mean, the algebraic structure don't match, and so whatever it is, it would have to be some kind of discrete thing or something. And that's exactly what it is, except it's not stupid. But so this is the restricted geometric Langlands conjecture that Dennis talked about briefly in the last talk. So I should say I think that the original motivation from Show and many one is to apply Riemann-Hilbert in a precise way, was to define a stack of Italian local systems on X when X is built over a finite yet. For us, yeah, we'll see that this restricted geometric Langlands conjecture will imply both the Betti and the Duran. Like it goes the other way around too. They're all equivalent. So this is the way you go between them. Okay. So let's.
What? Why was the whole previous thing about? Why was it about pen?
The domain of somebody. I mean, what do you mean? How far back in history should I go?
It's just okay. It's just like it's topological space. It's kind of a topological space. Like singular cohomology shows up in handy space. It's like Betty's looking like cohomology theories and that. So,
yeah. So for example, it's reflected in the fact that the sheaves you considered on the automorphic side, it's really sheaves on the topological space underlying the complex analytic. And also, if you just look at
Again, I think the question is why do we consider sheaves as the point, right?
called Betti? That's the question, right?
Sure.
So it's the motivic people who are responsible. So they call it the Betti realization function. The sheets. Yeah. So you have to ask them. I don't know who the first guy called that on this function.
So this one?
Yeah.
Ah, okay, yes, yes. Difficult to see. Go over here. So, yeah, so there's a very restricted geometric line of conjecture, there's a round one. I'll formulate the round one, but they're equivalent this time, though, in the metric. Let's do it. Well, let's return to the round case. Meaning x is over an algebraic with all field of characteristic 0. Yeah, and so already I suppose Dennis mentioned that there's this Fanakian description of the Milan modular stack of works to check, which are Lori, I suppose, in this up as right exact tensor pointers, magic model pointers from mutations P check, Q copy to check to S, that is a mix. And this is the kind of definition we'll use to find blocks restricted. Now, I'll define a subcategory, which I will denote coisilies or Qlies, subcategory of these D modules, subcategory of those D modules, such that each homology is a union of some vector bundles with a connection. Union of, if it's a coherent module, it's just each homology is also O-clear. Okay, well, now we can define the following stack. To define looks is restricted by the following requirement, the mapping into it is by definition the groupoid of right exact tensor pointers from representation of the check to QoS, not tensor T modules on X, but rather this subcategory of least modules. Okay. That's the definition. Yeah, so as we see from this Tanaka duality theorem, there's a map iota from the restricted stack to Roxas. And let's try to compare the geometries a little bit. So I'll just say there's the facts here. Namely, that iota is surjective on K points. So, what does that mean? It means that you have a symmetric unilateral functor, dx, and it automatically factors through x. And you can in the image here is dualizable. Like the symmetric unilateral structure here. Moreover, yeah, so this fact was used, this is the fact, we'll return to it, this is the fact that allows you to go from the derived to the restricted question. Moreover, they are an isomorphism of conformal completions. So there's sigma and log cis, which I mean a K point, won't write log is restricted. We get an isomorphism on the formal completion of this point. And formal isomorphism. Okay. And then the interesting thing is the connected components in some sense. So two local systems that lie in the same connected component of locus restricted. If and only if we have isomorphic semi-simplifications. The interesting consequence of fact 2 is that when you consider the substack of irreducible local systems, it kind of splits up as a disjoint union for each local system. So the connected component containing some irreducible local system is isomorphic to log system check, formally completed at point modulo statements.
What does that mean?
Yeah, so I mean, informally, you should, if you kind of look at the other side of Riemann notebooks, you just consider these representations of fundamental group. It's the usual thing, which kind of direct some of the irreducible subquotients. Here it means the following. So remark. We say some sigma is semi-simple if whenever it admits a reduction sigma p to log cis p check, it further admits reduction to log cis m checks to the levy. Whenever you reduce it to a parabolic, it further reduces to a levy. It's a definition of a semi-simple one. And then the semi-simplification is saying if you have sigma local system and sigma, let's say tilde, is a semi-simple local system. And we say that sigma tilde is the semi-simplification of sigma if they both have reductions. A little long. The reductions sigma p check sigma tilde p check to some parabolic p, and they become isomorphic after projecting down to the levee. That's it.
So it's probably to C1 and C2 and LSG restricted. You check.
But so I guess I said verbally, whenever there are K points, I won't write restricted because of fact one was bijection. That's
What is the state occurring in the second line?
the where
The
this.
second line from the top?
So take logs as G check, and you formally completed that point modulo the stabilizer of sigma. The classifying stack of the stabilizer of sigma.
Where I take a morphism from point to the stack by sigma.
Yeah, so should say it's the stabilizer or the automorphism group of sigma. So this maps into log as G check. Just any point modulo its automorphism group maps to the stack, and that's and in fact here it's a closed embedded if sigma is sigma. Okay, any other questions?
Yeah, so for the definitions of semi-simple and whatever is all parabolic and whether you like for uninitiated in the audience, what does it have to do with semi-simplicity?
Yeah, I mean, kind of if you manage your end for a second or something, so it's saying that whenever you kind of have a filtration on your representation, it was semi-simple. They all came from the levy, which is kind of taking the place.
Yeah, after we put it right,
Yeah.
all these Betti, what would be inside the text and the from maps to.
Yes, so
So this will be sheets instead of demon, all sheets in.
these will be new sheets, Betti of these sheets. Okay, so maybe there's a, yeah, so I should make a remark somewhere, I'm not erasing it immediately. Yeah, I'll just say it. So in the Betti setting, it's a subcategory consisting of finite range locals. Finite range locals.
Sorry, same definition, but there is.
Same definition, just replaces this category by subcategory of jointable sheaves, each one of those.
Why can't I take similar definition to this, that if they deal with sheets on all the sheets on?
If you could, you'll just absolutely get something its own.
Okay,
It's not at all there. So I should say that.
No, I think you just get books.
Oh, really?
Yeah, you just get books that it's all I thought this should be more analogous because the restricted things to be same in both setups.
Yeah, you say this thing was like restricted in all.
Yeah, okay. But I was asking, but yeah, so for log C is Betti, I just replace the effect by all Betti.
That works. Yes, alright. If you don't get some people.
The only difference in that is and the if constructible sheets versus Betti sheets. That's okay.
Okay. Any other questions? I have 20 minutes left. Right? The right state of restricted units of Langlands conjecture. It says that the category of E modules on 1G with nil close to the support. So again, this condition appears. This time it's the definition of singular support for D modules. It's with the support of an associated gradient of some filtration. You want this to be equivalent to same kind of thing in from it. Logs us to check. Okay. Let me also give some motivation as to why this should be true. Besides those coming from But this is kind of an analogous definition to the Betti geometrical Langlands vector. One is that ultimately we're hoping to apply Riemann-Hilbert, which you can do for. So there's an analogous Betti restricted geometric Langlands conjecture. You want to relate them by the Riemann-Hilbert correspondence. For this, you absolutely need the following statement. Namely that any object of milk 1G is a regular element. The monomicity is automatic because notice Lagrange regular monomicity is definitely not. Yeah, so as you say, here's an analogous Betti restricted geometric line. And well, they are further. I mean, at this point, it's not clear at all why this should help you. I mean, okay, now you have some intermediate category that at least allows you to go between the Betti and the round versions, but hopefully the Betti version is an E-Smith. And I don't think this will become particularly clear before Friday morning. Where I'll talk a bit about why the Langlands function in this situation is more well behaved. Morally, you can say it helps to have this conjecture because you can apply Riemann-Hilbert. If you have Riemann-Hilbert, you could start to apply micro differential geometric methods into proving the conjecture. Betti side sort of has the advantage that you can apply methods of microlocal geometry, differential geometry, and the Durand version, the thing there is that you can apply methods of representation theory of affine V algebras and stuff like this. This is constantly play off. Okay. More motivation. So given category C. Okay, so now this is what is called the big beautiful theorem. I think it's very close. So there's a statement here that given an action on this category, on another category C, giving an action is equivalent to giving a functor. Let you check tensor I, tensor C, you see tensor Q-lease X tensor I, all finite sets, non-into finite sets I, compatibly under subjections. Doesn't really matter too much. There's this characterization of what it means to give an action in a category. Of course, you want to use this to provide a spectral decomposition, the morphic category or the spectral one. And indeed, this happens. So a theorem of Nadler and Jung says the following. Consider the head action. So now we have a representation. You get an endofunctor. You can also do it kind of continuously over the curve. If you restrict the heck action to the subcategory of D modules with no potency singular support, this lands in this Curie's category. This is saying that sheaves with no potent singular support, the heck action is locally constant. If you're given some representation G check, one is a Taka sheet over spherical category living over X, the heck action at each point is essentially the same in evaluated of objects that have no potent singular support. So I just want to combine these two statements to say that whenever you formulate a geometric Langlands conjecture, one of your immediate goals should be to try to construct a spectral decomposition of the automorphic category over the spectral. This is what this gives you. Any questions about this?
I just want to say, like, just super down to earth, what it is, just like, for like, humans who don't know what a category is, but then try special functions, special sheets, like all the heck I, everything would.
Yeah, so you're saying if I'm interested in delta sheets, which ones heck I sheets, where are they? Yeah. A little bit afraid we're going to lose the humans that don't care about categories. Yeah, so in fact, something more is true, and this is what Denise also wrote it last lecture. But there's this nice characterization of having nilpotent singular support on Bun-G as the following tensor product. Okay. It's exactly what you would hope if you want both of the RAM and the restricted RAM to be true. Okay. Saying that if you have a D module on Bun-G, what does it mean to be decomposed to live over locus restricted, sitting inside locus? It's exactly the condition to have an important sequence.
Fantastic. So it's curious in here, characterized by the singular support being the zero.
That's right. Yeah, and so maybe another remark is at the time. This tensor product is very nice. Why is it nice? One funny thing, yeah, okay, this thing. Saying something wrong now, proving that any D module with nilpotent singular support is regular holonomic is a very non-trivial statement. Just apply the definitions of regular holonomicity, and having nilpotent singular support, you won't prove it. And these kinds of statements are used for that. Yeah, so to say this thing here gives you also that around geometric Langlands implies restricted. You just enter up with Q locus restricted once you have the Durham geometric Langlands equivalence, and you win. You can say the converse. Converse is also true. And then, let me not prove it, but it's kind of say the idea. that if you want to you have some Langlands function, you want to prove it in equivalence. Maybe you start by proving that it's fully faithful. That could be that's equivalent to some unit map or co-unit map being an isomorphism. And you kind of check that on k points. You can check if a sheaf is 0 on k points if you allow for all field extensions. So the fact that this map here has a bijection on k points is what allows you for this without. Yeah, for that one.
That's not really true, right? If that's an example of the generic point.
Well, I said all field extensions.
Oh,
Yeah. I didn't say it that loud because it rhymes so well.
This is not the objection.
Right, so it's not a bijection on all field value points. For example, you won't see the generic point. More effectively. But I'm not allowed to use this. This was the.
Yeah.
Okay. And so, I'll just repeat what you said, so this looks as restricted, like you say, it's drawn well, it's very, very much depends what field is started with.
And you, so it is equal for all fields, then it is, okay, then.
So on the last, we haven't defined temperature much for the long ones.
Sorry, final, so. You have a decomposition that, like, where's the corresponding decomposition on the board?
Okay.
For integral loxes restrictors, that shows you just canceling the building.
Okay. That's a good point. So there's a spectral analog, which is essentially trivial. There's that info. Nope. I'm gonna mess this up. Wait, I think on the looks as we check. Restricted is info nil looks as we check. So the Q code. This is what you were thinking about. Okay. Which one? This one?
The dark
Yeah. So the last one to be introduced is the tempered geometry lines architecture. Yeah. Yeah, so that's a similar, it's exactly the similar story. So everywhere I write df on G, you write the sheaf all nil from before, you'll get completely analogous decompositions, and the same proof shows that. Yeah, so for example, this Loxus restricted Betti thing, it's also a bijection on k points to Loxus Betti, and everything goes through the same.
T-chat listed.
Again,
LS T-chat listed.
where do you see that?
Torus. When G is a torus, what is?
That's a good question. See if I can do this. So Loxus into restricted. I'm not sure I have anything bad to say on the following. So it will be disjoint union over all rank one vector bonds to connection of you take Loxus GM and you formally complete it along point along region.
How did you correspond to?
Curve one to sigma, so.
Can you make that one?
All right.
Yeah,
So-
so.
Yeah, so Loxus GM. is a product of, let's see, EGM. We have, all right. Other people usually write. You're all right. Look. And so drive factor. Okay. So here log was the course moduli space of rank 1 vector bundles an X cross connection. Yes.
Just what about the Betti?
Yes, it's right, Betti.
Right. So I just have to tell you what looks of GM Betti is. Didn't I do this? Yeah. Oh, okay, I did. So GM to G comes with paired things GM. So this looks as GM restricted will be the joint union of points of, let's see what happens. So GM, we formally completed hash of point sigma. Nothing happens to this factor, and then get EGM formally completed on itself plus EGM. Okay. So it's just it's a disjoint union of all sigma. Get GM formally completed at 1. You get some stupid derived factor and we get EGM. There we go. All right. So this way you can also check that the RAM or Betti should be very
You said that the restricted version is a union of completions along semi-single points, but you also said the k points are the same as k points of local systems GJ. So how do these two parts live together? Because you have k points which are not semi-simple.
So when G is real and evidence.
No, not for G.
If you complete along the thing with the same semi-simplification, then you can almost semi-simple.
Oh,
Okay, yeah.
okay.
Without the confusion?
Yes.
Okay. Alright, I mean. Alright, let me just say, let me not define too much, but let me just say something about this tempered. So, tempered geometric alignments. In some sense, not as important as the others. It's just the following. So, you have the geometric alignments projected. Does this. And there's this annoying thing about constantly writing in co-nil, whatever that means, instead of QCO. You have your subcategory. Partial covariant fields, as we saw in Tina's talk. So there should be some analogous subcategory on the orthomorphic side corresponding to it. You can define this intrinsically. Maybe I should just do that real quick. We can define this before I do that. We can define the set of 40. And just the thing to take away from this is that we've already kind of hinted at the fact that the center of geometric alignments implies geometric alignments conjecture. In fact, it's kind of how behind it. This pointer back through this. So it's kind of the centerness is built into it. And yeah, as we saw before, the Langlands function in the temporary case is more well behaved. With cohomological amplitude. Let me just write it real quick. Okay, we can ask how to characterize quasi-coherent sheaves on lopes, inside incoherent sheaves. and some kind of edit into it. The answer is to choose a point curve. Then the following composition to go look this is in the middle. Transfer over and come out of this category. Okay, maybe I'm writing some stuff. I'm not sure this is actually quite helpful. So this is the spectral Sataka category acting on boxes. So there's an action of this category on the spectral category, we're covering the usual static action, the usual spectral action, which you can also now we'll point out like this. And we'll just mimic this, construction on the holomorphic side to get a definition. Namely, we have the derived Satake equivalence. Derived Satake tells you that D modules on this local vector stack, so you've seen several times, it's equivalent to incoherent sheaves, maybe with no further single support on this root stack. So we just define the centered quotient, centered subcategory as a power thought. Defines the the definition, I don't really care what it is. It's the definition you come up with if you want something to correspond to Q government.
But actually, the MST question is really doing very like the thing I would naively say is just like take one tree and pass them one tree. Over a sheet.
Oh, that's another definition you can know.
Yeah, and so why is it the more like how we're you just start well.
Yes, you just say everything, like everything, basically you get from the acting on the generation. Why is this more natural?
Yeah.
Yeah, some sense of, but we can all do the same.
Okay.
So, yeah, in terms of that are not your fault, but that's the previous speakers, that were 40 minutes over time.
Okay.
And the maybe.
Yes, but that's all I wanted to say.
Okay.
So, okay, thank you.
I guess there are no questions. There's a practical announcement though.